This video covers Chapter 6 in our class for EE160, Chapter 6 of our textbook from DITEL and DITEL. And this chapter covers arrays. Everything is about an array. And I put the Wikipedia definition of array just for the fun of it. But one of the things that is important, it's an ordered arrangement, a collection. So even an English definition, array is a fair description. Oops. So an array is a fixed number of data items and that they are all of the same data type. So they're all ints, they're all characters, they're all doubles. So the array has one variable name, but it's a collection of the same data type. It occupies in memory contiguous memory locations, and we will show you that later on. I think a different video. And you can store many data values of the same particular kind. We will note that in C there is also a data structure called a struct structure, which can have different types, and we cover that in Chapter 10. So how do you define an array? I have some examples here, and this is an array of integers, and it has 5 values on it. In it, if I declare my array without initializing it, the 5 values stored in the array will be garbage. So garbage is something that's not been initialized. It won't be zeros, it won't be nulls, it will just be arbitrary numbers. Another way to initialize your array, I could initialize it with all zeros. I could declare an array with 5 elements in it and put all zeros in it. So this is valid syntax to declare everything as all zeros. And then I have another example where I declare an array C with 5 elements in it, and these are the elements, the integers that I'm going to put in it. And lastly, I can declare an array C and put it in empty brackets. Note that they are square brackets when we're talking about an array. And then if I give it 5 elements, it will be an array of size 5. So I said that when you store elements in an array, it's all contiguous. So here's an example, a C with 12 elements in it. And here's the elements stored in contiguous memory locations. How many bytes it takes depends on which data type you've declared. So for example, a double I think uses 8 bytes. So each memory location will have 8 bytes of space allocated to it. These are called the elements, C0, C1, C2. So this is the indice. The 0 is the indice of the element. So the 0th element of the array, the value is -45 stored there. But if I wanted to refer to that memory location, I would say C element 0. Notice the elements start with 0, not 1. So I have an array of 12 right here, but the indices, how you refer to the array elements, starts with a 0. Let me give a quick example there real quick. So if I wanted to have a piece of code that needed to get the 4th element in the array, I would, and maybe I needed to use it somehow with my program. Let me get my pen here. So maybe I needed to get the 4th element. So which one is the 4th element? This is the 1st, 2nd, 3rd, 4th. So the 4th element is C element 3. So maybe my program needed to get that element, and I could say int x, for example, and then say x gets assigned C element 3 in my code. And then if I were to see what the value of x has, x would be then the value of 72. If I were to do a print f x and print the value of x, it would be 72. So you can, talking more about defining arrays, another thing that you can do is use a constant for the size. So one of the things that you can do is use this define preprocessor directive at the beginning of the program. Notice it's before the main. It's where the other preprocessor directives are, like the include standard I/O. I can do a define size equals 3. Because it's a constant, our style convention says constants should be named with all capital letters. That's how you identify it's a constant. The program really doesn't care, but that's our style convention. So if you name a constant, it's all capital letters. A common programming mistake is to put a semicolon there or say size equals 5. No, that's not true. This is a definition. So include standard I/O is a preprocessor directive, but defining something is also a type of preprocessor directive called a macro. So a macro is an instruction to the preprocessor that happens during the compilation before the compilation. It's a message to the compiler before the compiling of the program begins. So macros can be complex, but macros can be something simple, like we're doing right now, such as defining a symbol called size. And in the program, size, when you use size, it will be replaced by 5 wherever the symbol appears. Note that size is not a variable. It cannot be modified in the program. So once you define size equals 5, it is defined that way and can't be changed. I like defining pi, for example, 3.14 or whatever, how many digits you need. I like to define pi outside the main body of the program because it's useful there. So here I use the constant that I defined. So I declare an array called C, and instead of putting a number there, I put size. So this brings up a point about programs. In general, good programming practices is to not have a thing called a magic number. So no magic numbers in programs. I'm going to add that to my eval sheet for your program. So magic numbers are numbers that you suddenly use in your program, real literal numbers that you use in your program, and it's not been given a name. So for example, if I say in a program that I'm going to do a for loop, int x equals 0, x less than 10, x increment. And then I have some body of whatever I do in the for loop. This number 10, this is a magic number. Why is it 10? So from here on out, you should never ever define your for loop with a number in like that. So why, somebody will come back later, why is it 10? So a more proper way to define this, 10 is a magic number, right? By the way, so that's what a magic number is. Just some number that shows up in your program, and then somebody else looks at it and says, why is it 10? So maybe I have in my for loop, for x less than max, maybe you called it max size or something like that. Anyway, so then you'll define somewhere in the beginning of the program, it could be a constant, or it could be somewhere in this part of the problem where I defined int max size equals 10. If it's variable. If it's not variable, int cap letters max size, all in cap letters, equals 10. So although we use this define statement right here, that makes it a definitional thing throughout the entire program. You can also define a constant just by capital letters, just like we do our normal variable declarations. You can define it that way for your program. So if max size might change somewhere in the program, you write its variable declaration with lowercase letters in camel casing. Remember camel casing. If max size is going to be constant forever in the program, you do its variable declaration with all capital letters. If it's something like pi or a real constant, I would define it up here with my preprocessor directive using define statement. So let's look at a first example using an array. This is just a little program that initializes all the elements of the array to 0. Now keep in mind I could have done something simple like this, which would have been much nicer than doing it the way I'm going to show you. Well, maybe I want to initialize all the elements of an array to 100. Maybe that would be a better example. But anyway, so here's a way to write values to the elements of an array. That's probably a better example. So I declared my array n. Bad name for it should have more meaning, but this program doesn't really have any meaning. And then I just used a for loop to fill in the values of the array elements. So basically all I did is go through the for loop 5 times, and then I say n element I gets a 0. So then every element of n will get assigned a 0. And if I run the program, I get a result that looks like this. So I have a print statement that just prints the header information here, and then I print out the value of every element of the array here using another for loop. So I print, I give 7 spaces for the unsigned integer I, which is the element number of the array, and then I give 13 spaces for the integer value that's stored in each element of the array. There is one other new thing in this program, and that's the use of it's the use of size t right here. So this is a new, looks like a new data type. It's actually not a data type. It is a integer, or sometimes it's a long, that's defined in either the standard IO header file or the standard definition header file. It is used for the iterator type in arrays. So size t is used in defining, working with arrays a lot. I actually never saw it before this textbook, but since your textbook uses it, I pointed it out. So I probably would have said for int I equals 0 and declared it anyway, because in my iterator I is an int after all. But anyway, your textbooks use the size t, so I'll point out the size t. Now one thing, if I used the size t, or if I had this be an int I, could have been int here. In any case, with our compiler that we're using, I had to compile with the additional option -standard equals C99 for the version of C that we're using. So if I were to compile this program, I need that little additional option. Otherwise, I have to declare this data type outside the for loop. And we've seen that before. What we haven't seen before was the use of size t. And since your textbook used it, I brought it up. So now let's do some examples. I'm actually going to look at 4 examples from your textbook, but instead of looking at it in blue and gray like the textbook has, I'm going to look at it in Notepad++. The first program is just going to sum the elements of an array. You can probably already guess how to do that, because I showed you how using a for loop, you can use a for loop to go through each element of the array. 6-7 is a neat problem. Very good example of how you would use an array. 6-8 is an extension of that, doing a little graphical thing. And 6-9, we're going to roll the dice 60,000 times and summarize the result into an array, rather than previously when we rolled the dice a bunch of times, we had, I think the output was frequency of a 1, frequency of a 2, frequency of a 3. So we had 6 different variables to store how many times that number occurred on rolling the dice. But this time we'll store it in one location. We'll store that result in an array. So let's look at the programs. So the first one is example 6.3. Actually, I already did example 6.3. Here I just cleaned it up a little bit with the excessive notes that they were, the excessive comments that your textbook likes to do, which is good. I mean, it explains things. So I used the size t operator data type to work with the array here. I put zeros in each element of the array, so as I go through the loop, array element 0 gets a 0, array element 1 gets a 0, array element 2 gets a 0, etc. And then I print out the results. Okay, let's look at problem 6.6 next. Compute the sum of the elements of an array. This is what happens next. So here they use the define preprocessor directive size to be 12. I'm just saying you could have said the same thing up here at the beginning of your main, where you often make your variable declarations. So anyway, I declare an array called A. The size of the array is size. Size is defined up above. I initialize it with these values. And since we're finding the sum of an array, I declared a variable named total. Total gets a 0. So now here's the for loop that sums the contents of an array, the array name being A. So I use the size t data type again. So for I equals 0 to I less than size, increment I, and then the sum, the total, plus equals each element. As I go through the for loop, each element 0 becomes the total. Go back through the for loop. Total now gets added with element 1. We'll add in element 2. We'll add in with each element. We'll add in through each iteration of the for loop. And then I just print the total of the results. So that's how you would sum up all the elements in an array. 6.7. I like this problem. Let me just go back to the problem statement. This is a very typical application of why an array is useful. So 40 students were asked to rate the quality of the food in a student cafeteria on a scale of 1 to 10. 1 means awful and 10 means excellent. Place the 40 responses in an integer array and summarize the results of the poll. So summarizing the results of the poll is basically saying how many 1 ratings, how many 2 ratings, how many 3 ratings, etc., and summarize those results. So let's look at the program. So there were 40 responses, so we did a preprocessor directive defining the responses size is 40, and then this definition, frequency size is 11, comes from the fact that, and this is where you have to be careful using an array, we have 10 responses, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But when you declare an array, it starts with element 0. So I could write this whole problem where my 10 response bins, they're called bins, the places where you count the 1 response, the 2 response, the 3 response. I could make the program make an array between 0 and 9, put the number of 1s in array position 0, the number of 2s in array position 1. Let me write that. Well, the way this program chose to do it is define the array to be of size 11, and which would mean elements 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. That's 11 elements. So, let me walk through this program a little bit. So here we declare an array called frequency. Its size is its size is 40, and I've initialized it to all zeros with this line of code. Now I'm going to, this was an unnecessary step in a way. I could have done it all in one step, but the next step here, I place all of the responses from the poll into an array. So this step was unnecessary. Oops. I initialized, no, this was not an unnecessary step. I'm sorry, I said that wrong. This is where you're putting the results, the frequency of each poll response. So here I initialized it all to 0. That's proper. If I don't do this initialization step, then the array has garbage in it. That would be fun to show. I should run the program that way and let you see it. Then I create the array with all of the responses from the poll right here. Then I use my for loop, and notice I have no magic numbers. So for answer equals 0 to answer less than the response size, which is 40, go through each answer. And what you do, this is kind of interesting. Let me write that, what's happening here on this piece of code, because I'm going to go over it for a moment because it's interesting what they did. So through the magic of pausing, I have put relevant parts of that code onto this sheet so I can write on it and show you what's going to happen. So we have this array called responses, and there's another array called frequency, which I didn't put on here. So what happens here in this for loop, that's the interesting part, and the key line is this line right here with the plus plus frequency element, and the element is response element answer. So what's answer? Answer is just a loop iterator here, so I kind of thought that that was misnamed in this example. But anyway, so answer is our loop iterator. So we go through the loop the first time, and I get responses element 0, because answer is 0 when you go through the loop the first time. So what is responses element 0? I look at the array up here, and responses element 0 is a 1. So I'm going to go ahead and write that in my little chart here, because that's what I was trying to point out. So I have the names of my memory location, which is responses element 0, responses element 1, because this is all part of the responses array. So what's in element 0? It's a 1. What's in, so responses element 0, and 0 is from that loop iterator, is a 1. Go through the loop the next time for that example. Responses element 1 is a 2. Responses element 2 is a 6, etc. But let's look at what's happening through the first time through the loop. Answer equals 0. Responses element 0 is a 1, right? Because that's the responses array. And then it says increment some component of the frequency array, but we're incrementing frequency element 1. So from this part right here, because this came out to be a 1 when answer was a 0, this value was a 1, so I'm incrementing frequency element 1. So this is my incrementer. So I'm increment frequency element 1, because this 1 is frequency element there. That's the element. So I increment that. Then I go back and go through the loop a second time. So now answer is a 1. I say, what is responses element 1? Responses element 1 is a 2. And it says increment frequency element 2. So I'm just going to put like a counter here. I'm going to increment it here. I go through the loop the third time. Answer is now a 2. So third time through. Third time through. So first time is 0. Second time is a 1. Third time is 2. So third time through, it's responses element 2. That's 0, that's 1, that's 2. That's a 6. So responses element 2 is a 6. Now I'm going to increment frequency element 6, which I actually didn't show down here. Oops, 5, 6. So this one will get incremented. etc. And you go all the way through the loop, no answers are ever 0, so no value is ever going to be put in frequency element 0. That's the part I didn't like about this program, but this is a place where people can go wrong. You can work this problem several different ways, but be careful of having what's called off by 1 errors. So one of the reasons we initialized the frequency array with all zeros is because that will have a value of 0 in the end. So now if I go through and do the program, so I just was going to compile it and I got a compiler error because size t wasn't recognized, so I have to put that extra option on, dash standard equals C99, and then I run it, it ran fine. Ooh, can't see things here, can we? And there it ran. So it gave the frequency of how many ones there were, how many of each rating there were. It printed out the frequency of it. So very nice. Next example is displaying a histogram. I could have done it with the problem I just had, displaying the results as a histogram, but basically we make a little graphical figure that shows I'll say the magnitude of the answer. So here I've declared an array of which is size 5. I've used my define up here. I put a few numbers. It could have been the numbers from the problem we just did in an array. And what I want to do is print out some kind of a graphical display of what these numbers are. And so here I used that fixed value size in my loop, and all I'm going to do is output a bar of the histogram. So you'll see the result in just a minute. So this is just making it look good, but here's the actual histogram. So you see what the value of each element of the array is. So the first one is 19. So well, you go through the array, excuse me, go through the array n1, n2, n0, n1, n2, n3, n4, and as long as you are less than, this is nested. As long as you are less than element I up here, you're going to print the histogram stars. So we have a nested for loop in this case. And the result looks like, and you get a pretty result. So the histogram is a bar graph basically of the size of the value. You can do histograms horizontally, you can do them vertically. So this is a horizontal version. So there's 19 stars there, there's 3 stars there, there's 15 stars there. And then this first loop took care of outputting this information, and then how many stars that you put out was from the second, the nested loop. Look back at that program for a minute. First loop puts out First loop puts out element 0, and the value of element 0 was which was a 19. So that's what they're doing here with this for loop. And then it prints the number of stars on that line. Notice that there's no new line here, so the stars are printing on the same line. So it'll print out the number of stars depending on what the size of that element was, which in this case was 19 on the first line. So nice use of nested for loops to print the stars. So the last example of this section, we're going to roll the dice 60,000 times and summarize the results in an array. But before I do that, I'm going to go back and this is an improvement from problem 5.1.12. So let's go back and look at 5.1.12 for a moment, which was in the last chapter, focusing on random numbers. So what we did in this one is we looped 60,000 times, and then we stored every time that you got a 1 or every time you got a 2. We had to create these variables right here, and then increment them, those specific variables, by using this case, the switch structure. So if we roll the 1, this is the part that rolls the dice, right? Which you're going to see that part again in the new program. So every time you roll the dice, you get the numbers 1 through 6, and then you go into this switch structure, and if you roll the 1, you incremented the frequency 1 counter. If you roll the 2, you incremented frequency 2 counter, etc. So let's look at the improved program now. Here's the improved version. We still have 6 numbers to deal with. This textbook likes to declare an array of size 7 because of the counting by the element number. So we have an array of size 7 whose array elements are frequency element 0, frequency element 1, frequency element 2, all the way up to frequency element 6. That makes 7 elements. We declared our array, seed the random number, and here we roll the dice 60,000 times, just like before, only instead of then going into a switch structure, we're going to increment frequency element. It's going to end up being frequency element 1 through 6 to count how many times the values 1 through 6 occur. There will be a frequency element 0 in this array that will have the value of 0, and we did have to initialize everything with zeros right there, and then we just print the results in the end. So this is a fun program to run. Let's run it. So I compiled it. I'm getting ready to run right there. Let's run, see how long it takes. Oops, run. It ran fast. No worries. So, and then it put the results in one of, this happens to be element, so element 1 got incremented that many times, 10 million plus times. Increment, did I say 60,000? It's 60 million. Number 2 occurred this many times, number 3 occurred this many times. And this is the contents of the array called frequency. The array was called frequency, but this is the contents of element 1, element 2, element 3. So if I looked at the contents of frequency element 0, it would be a 0 because we initialized it to a 0. So now we can talk about arrays of characters. So C does not have a data type called a string, which is a little bit inconvenient at times. So instead you have to make an array with characters. Other languages, by the way, do have a data type called string. So and I have a little piece of code example right here, and I created an array with data types are characters, and I have empty so it can be whatever length, and I typed in some letters. That's the easiest way to make your character array, is not to specify the length of the array and just type in your string right here. And then you can display it. There's a print statement. This is the print statement that displays the string that I just put in the array, or the array of characters that I just put in. But there's another new thing that happened right here, is I want to say how many characters this string is, and I used a function called string length. And the string length function and other character functions and string operations can be found by doing an include string.h in your preprocessor directives. And if you recall, we had the NCC reference card, and on there is a list of everything that you can do with if you've included string.h at the beginning of your program before you compile. So we will have more of that soon, and it's not been brought out much in your textbook, so you're going to have a homework problem that uses some of these string functions. So I can make a program that says how long is this string, and it will return how many characters are in this string. Or I can just print out, notice the string format specifier being used right here. So all strings in C end with a null character. So after this exclamation point up here, there is a null character that you cannot see. So you have to be careful when you define, if I were to define a length here for this string array, character array, I have to be careful that my length accommodates the array that I want to, the array of characters that I want to put into it. So here's an example of getting user input and putting it into an array of characters. So I created an array called input string that is of length 20, but when I read in from the user, I said that I could get 19 characters from the user and store it. Ooh, there's a little mistake in there. You see my syntax error right there. But and then I can print back out the string. So I created an array of length 20, but it can hold at most 19 characters because of the null character at the end. And we can run this program. So we run this program. I've already compiled it. So that was the first part of the program where I said C programming is fun and challenging. I counted how many characters there are, and there are 37 characters there. So here's the next part where it says I created an array of 20 characters, and then I have an input with 19 characters. So let me put in a string of 20 characters, or more than 20 characters. This is how I'll do it. I'll say 1, 2, 3, 4. Remember, these are each characters. They're not integers. They're characters. 5, 6, 7, 8, 9, 10. I'll put a 0. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And I'll run it, and you will see that it only takes in 19, even though I declared the array to be 20 characters, it will only take in 19. So there's a null character there that you cannot see. Here I modified the program a little bit. I still declare a character array of size 20, but I allow the user to enter 22 characters and store it in the array, and I now have my syntax correct, and then I'll print back out what occurred. So if I run this program, there I ran it. So I was, we'll run it again just for the fun of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's 20, which I made my array a size 20, 21, 22, 23, but I specified an array size of 22 for the scanf function. But 1, 2, 3, 4. Oh, wait, I learned something new. It accepted 22 after all. Ooh, that's interesting. So I declared it to be 20, but it accepted the 22. It must have modified, since this is variable, my input string. Bad programming practices, though. You could get yourself in trouble not keeping track of things. I think that's a little inaccurate in your textbook, because it says, previous example, this will accept 19 characters even though we declared an array of size 20 to accept it. And it did take 19 characters. This one, I declared an array of size 20, and I tried to put 22 characters in it. And it actually, and I entered 23 characters, but it put 22 characters in. So even though I declared the array to be size 20, it lengthened and took the 22 characters. Might get myself in trouble programming that way. So taking another look again at that string.h header file and the functions and operations that you can get from it. We did string length, copy, string copy, so you get string and then other characters that you can copy of another string. This one, concatenate, so I want you to know what concatenate means. Concatenate the second string, which is CT, after the first string, which is S, and then you can optionally have it up to n characters of it. So let me demo that a little bit. Well, first here's the program. So here I defined a first string, string 1, good, bad, and string 2 says and ugly, and I can string concatenate string 1 and string 2 completely, and when I do that I will get the results. Good, bad, and ugly. Hey, how about that? So let's play around with it a little bit. So what if I concatenate string, oops, let me get the real program. Concatenate, oh, I did have a question. Did I have to say specifically? I don't think I do. So let's try that real quick. No, works just fine. Okay, just double checking that. Okay, so I could also have the option of the command with up to n characters. So let's try that up to n characters example. Okay, so string 1, string 2, 3 characters. What do we get? Save it. So you can cut off the end of your thing as expected, end of your string. So I see I'm at the 41-minute mark, so it's time to cut off this video. Our next video will talk about functions and arrays. So passing an array to a function and having a function use either an array or elements of an array. Bye for now.